Hey guys, in today's video we're going to be going over NOR gates. So this is the truth table for NOR gates. As you can see, it's the opposite of an OR gate. So in an OR gate, you would usually have, if one of the inputs is 1, then you'd have a 1 value, but because this is a not OR gate, it's basically inverting an OR gate. So you'll see if it has a 1 in its input, then it returns 0, and it only returns a 1 when both inputs are 0. And you can see this is the formula for NOR gate. So you basically add the inputs of the circuit and then you invert it to get the C value. And this is what the NOR gate will look like in a circuit. Rather than seeing this transistor schematic, you'll just see this symbol here. Alright, so let's just go through and I'll show you how exactly this circuit here works. So as you can see, there's just 2 PMOS and 2 NMOS. So this is similar to the NAND gate, except it's kind of an inverted setup. And you can see this is our A, B inputs, and this is our C output. And we'll just go through a couple of these scenarios just to show you how this circuit actually works. So let's go through this first scenario here, right? 0, 0. So our input A is 0, input B is 0, A 0, B 0, and we should expect value C of 1. Alright, so when we put our PMOS to low, it turns on, right? So this is a closed switch. When we set the gate of the PMOS to low for this one too, it also turns on. And when we turn these NMOS to low, these turn off, right? So because these turn off, there's no as current. So if we imagine current will travel through here, and because both of these are off, there's no path to ground, so they all lead through the output. And as you can see, that'll yield a result of 1 on the output. Now let's go through another case just to show you that this actually works. We'll go through this case here. In this case, we'll go through this 0, 1 case. So if you imagine A is 0, B is 1, A is 0, A is 0, and B 1, and we should expect a C value of 0. So we can just look at this. If the base of a PMOS is 0, we know that it turns on, and if the base of a PMOS is high or 1, we know that it turns off. And if the NMOS is, the gate is off, then this turns off, and if the NMOS gate is high, then it turns on. So as you can see, as current travels through here, because this transistor is off, it can only get through this first transistor, but it can't go through here to the output. So there's basically no path for the current to travel, and as a result, we get no output on C. So, and then we'll just go through the last case here, 1, 1, just to show you guys this case. So, just erase these values. And here. So, 1, 1, 1, 1, we should expect the value of C of 0. Alright, so remember when we set the PMOS gate to high, it turns off. So these two turn off. When we set the NMOS gate to high, they turn on. So these turn on. Because both of these transistors are off, or in what would be like an open switch state, no current is able to travel through to get to this output. So basically we see by putting the A and B values to 1, there's no way for current to travel to the output, and thus we get a 0 output. And that basically sums up everything you need to know about NOR gates. Thank you.